Welcome to this training session on ISO 18336 Quantitative Chemical Analysis, Part 6, Mixtures of Viscous, Certain Types of Cupro, Modal or Lyocell with Other Fibers, using Formic Acid and Zinc Chloride. This session is designed for textile testing laboratory personnel who perform fiber composition analysis using chemical methods. Throughout this training, we will follow the structure and procedures defined in the ISO standard. The objective of this training is to provide a clear understanding of the ISO 18336 method. You will learn about the scope of application, principles of the test, required reagents and apparatus, and the detailed step-by-step testing procedure. We will also review calculation of results, correction factors, and quality control practices to ensure precision and reliability of test outcomes. Scope of the method. This method is applicable to textile mixtures containing viscous, cupro, modal, or lyocell fibers with cotton or with other specified fibers such as polypropylene, elastolfen, or melamine. It determines the mass percentage of each fiber type after selective chemical dissolution. However, the method is not suitable for materials where the cotton has undergone extensive chemical degradation or where the cellulosic component is incompletely soluble due to the presence of durable finishes or reactive dyes. Principle of the test. The test principle is based on chemical dissolution. The cellulosic fiber, such as viscous, cupro, modal, or lyocell, is selectively dissolved using a reagent composed of formic acid and zinc chloride. The undissolved fibers, such as cotton or synthetics, are then filtered, washed, dried, and weighed. The mass of the remaining residue, when compared to the original sample, allows us to calculate the proportion of each fiber present in the blend. Fiber types covered. The soluble fibers under this method include viscous, cupro, modal, and lyocell. The insoluble or resistant fibers typically include cotton, polypropylene, elastolfen, and melamine. A preliminary solubility test should be performed whenever the fiber type is uncertain, to confirm its compatibility with the reagent system. Limitations and applicability. This method has certain limitations. It must not be used if the cotton component is chemically damaged or if the soluble fiber has become partially insoluble due to cross-linking, finishing agents, or dyeing with reactive dyes. Additionally, all non-fibrous matter such as finishes, oils, or sizes should be removed prior to analysis to prevent interference with dissolution and weight measurements. Reference standards. ISO 18332-6 must be used in conjunction with ISO 18332-1, which outlines the general principles for quantitative chemical analysis of textiles. ISO provides the foundation for sample preparation, reagent handling, and calculation of fiber composition. Reagents and preparation. The key reagent is a formic acid and zinc chloride solution. It is prepared by dissolving 20 grams of anhydrous zinc chloride with a purity of at least 98% and 68 grams of anhydrous formic acid, making up the total to 100 grams with water. If zinc chloride other than fused anhydrous grade is used, its solubility performance must be verified. Additionally, a dilute ammonia solution is required, prepared by diluting 20 milliliters of concentrated ammonia to 1 liter with water. Apparatus and equipment. The apparatus includes a glass-stoppered conical flask of at least 200 milliliters capacity and a heating device capable of maintaining a temperature of 70 degrees Celsius within a 2-degree tolerance. Other required equipment includes a filter crucible with suction apparatus, an analytical balance, beakers, a thermometer, a glass rod, and a drying oven. All apparatus must be clean, calibrated, and free from residues that may affect the mass measurements. Test procedure. Begin by weighing the clean, dry specimen after removing any non-fibrous matter. Place the specimen immediately into the preheated conical flask maintained at 70 degrees Celsius. Add 100 milliliters of the prepared reagent for each gram of specimen. Stopper the flask securely and shake it vigorously to ensure complete wetting. Maintain the temperature at 70 degrees Celsius for 20 minutes, shaking the flask again at approximately 5 and 15 minutes. After digestion, filter the contents through a pre-weighed filter crucible. Wash the flask and any remaining fibers using additional reagent and hot water at 70 degrees Celsius to ensure complete transfer. Continue washing the residue thoroughly with hot water. Then, immerse the crucible and its residue in 100 milliliters of cold, dilute ammonia solution for about 10 minutes, loosening the fibers gently with a glass rod. Finally, drain the crucible by suction. Filtration, washing and neutralization. Following ammonia neutralization, rinse the crucible and residue thoroughly with cold water. Allow each washing liquor to drain naturally before applying suction to avoid fiber loss. Once rinsing is complete, dry the crucible and residue in the oven, cool to room temperature, and record the final mass. This weight will be used for the calculation of fiber composition. Calculation and expression of results. Calculations follow the general principles described in ISO 1-83321. The correction factor, known as the d-value, is applied to adjust for any differences in the residual fiber mass. The standard specifies d equals 1.00 for viscose, cupro, modal, or lyocell, 1.03 for cotton, and 1.01 for melamine. The percentage composition is determined from the corrected dry masses of each component. Precision and accuracy. When testing a homogeneous textile mixture, the confidence limits of the results should not exceed plus or minus 2 percentage points at a 95% confidence level. To achieve this precision, ensure consistent sample preparation, accurate reagent concentration, and stable temperature control during the dissolution stage. Repeat testing is recommended if results fall outside the specified tolerance. Safety, good laboratory practice and summary. This method involves the handling of hazardous chemicals such as formic acid and zinc chloride. Always wear appropriate personal protective equipment including gloves, goggles, and a lab coat, and conduct all operations in a well-ventilated area or fume hood. Dispose of chemical waste according to environmental and institutional regulations. Maintain accurate records of reagent batches, test conditions, and calculation data. To summarize, ensure proper sample identification, precise reagent preparation, controlled heating, and careful weighing. Consistent adherence to these practices ensures reliable results and compliance with ISO laboratory standards. Thank you for joining today's session on ISO 1-83321. I hope this training has given you a clear understanding of the procedure and its importance in textile testing. If you found this session useful, please share your feedback so we can continue improving our training programs for you.